Hey guys, welcome to our brief intro to the solubility equilibrium lab. I will record, as always, a separate video about this particular experiment, but I wanted to walk through kind of what we have here. Now, there is no Alex for this particular experiment because there's nothing equivalent in Alex to what we're doing. So all you have is the data that's been given to you and the information from the lab manual. Now, there is a spreadsheet that goes with this one. Experiment 4 is a solubility equilibrium to understand the effect of common ions on solubility. So there are a couple of places where there are common ions, all right? So there are 4 titrations that would be done in the physical lab. One is for silver acetate alone. One is for silver acetate and potassium nitrate, okay? So that soluble salt has no effect. One is for silver acetate and silver nitrate. So the silver ion is common in both. And one is silver acetate and sodium acetate. So the acetate ion is common in both. Okay. You're going to be setting up your notebook with the tables in the free lab. I want you to make sure that you've done that. Class average will be obtained by you from the data I will send after class. Okay, so I will be sending you some additional data that you guys can use to do this. This is after we physically do this lab. I'll send you that data. Okay. There are questions 6 and 7 that need to be answered before you do the lab, and the reason for that is because okay, when you physically do the lab, we need to make sure that you understand what it is you're looking at. So that's why we do that. Now, fortunately for you guys, you're not actually physically doing this experiment because if you do this experiment and you get the silver on your hands, it turns brown. And that's because it's photosensitive. Okay, so we use it in developing photography. It is one of the ways that is done. It oxidizes in the sunlight, so you get the silver on your hands, you go outside, and you turn brown. It's not going to hurt you, but it will look a little weird for a couple days. So at least you won't have to deal with that. Typically, what we do is I have my students in the lab run this in groups, so that they're not doing all 4 of the experiments themselves, each one of them. Okay, they share things. So that is something that you guys will see in the data that you'll be presented with. Again, you will get more data after my class physically does this, just because I want you to have that experience of what it's like to have other people's data. I will also tell you that since you're not doing this in person, it doesn't really matter, but this is a very expensive solution, so we're very careful about how we do this, right? So that's stuff about that. So 4 titrations. One where it's just the silver acetate, one where it's silver acetate with another species dissolved, but it's completely soluble. That's potassium nitrate. One where you have silver acetate and silver nitrate, so silver ion in common, and then one where it's silver acetate and sodium acetate, so acetate ion in common. All right. Come on. Again, this is meant for you after you've started looking at the laboratory, and we've talked about the lab in its own video. This is information that's being presented to you so that you know where some of these answers are in the lab manual. Again, I will be providing you data from what is actually done in our physical laboratory. So you'll be able to look for 6A and B, make sure that you record the molarity of the bottles that were used. Okay, so you'll be given that information. You need to calculate the number of moles from the data. And then using that data, you need to be able to calculate KSP for beaker A in question C. Question D and E, same type of calculations as for A and B, but for beaker D. F is the same as C, but this time for beaker D. So if your data is different than what the accepted value is, what might some of those reasons be? And of course, things that you might want to consider is, how was this experiment done? Did we have anything that might have caused issues? So are there potential contaminants? Is it that something might have caused you to measure that precipitation wrong? Is it that we didn't notice the first signs of that solid forming, things like that. Those are things that I want you to be thinking about. And in terms of the post-lab, you'll need to talk about why it's important to know what the actual formula is to be able to determine KSP. Okay, so that's important. You may want to use the example for MgCl2 versus MgCl and what would happen if we looked at the two of them. Explain, would you expect the value of KSP to change because of a common ion? Okay, what changes, what doesn't? I think that's everything I want to talk about right now. So we'll talk about this again in more detail when we talk about the lab itself. But all of the things that we're looking at here are going to be part and parcel to either calculations that we're doing here or calculations in the common ion experiment, which is why we're actually doing this not today per se, but after the next lecture. So there will be calculations involving both for that. So this will be a good experience in talking about both KSP, calculating KSP from experimental data, and in looking at the effect of a common ion. Okay, so that's everything I've got for now. I will come back and talk about the lab in detail in a bit. All right, I'll talk to you soon. Have a good